Welcome back. Did you know that the Build Team Slack channel was created a year before the bazel Slack channel? I learned that from our next speaker, George Gensure, who is a Build Team Slack admin, active contributor to Remote Execution Working Group, and creator of buildfarm, a journey that I've personally seen evolve from its very early days of not much contributions from the community beyond George to becoming a popular, scalable platform used by large organizations. Today, George will talk to us about log reading as a service.
Hi, I'm George Gensure. My presentation here is log reading as a service. This might be a little bit different from some of the other presentations going on today. We're not going to be talking extensively about new technology or migration or particular adoption of one service or another. Log reading as a service is a shout out to my activities on build teams prior, where on a regular basis, we were mostly called upon to divine the meaning behind cryptic log messages, or at least people said they were cryptic until they got to us where we read them and tried to make some sense out of them. The skill set required to do this is not incredibly high. What I like to say is that the log was printed in front of you, person that reported an error, but some of the aspects of those logs in general, whether they be from CI, from build outputs, test outputs, or some specific thing, what those people usually lacked is either a partition in their mind about where logs come from or where boundaries started and stopped for how those things were reported, or a sense that they would either need to try to sequence those ideas in their mind, or in general use those logs not just as a stopping point for information, but also to dive into the actual behavior for the individual programs that they were running. So our goals here today are to discuss a logging philosophy. And there's a bit of build farm packed into here. It wouldn't be a presentation by me without that. So, but in general, the skill set that we need to observe logs and understand what goes into them means that they do not exist in a vacuum. They are trying to tell you a story. They are trying to accomplish a goal and convey a message, and not just necessarily the individual message that your build failed, your build succeeded, how long it took, or what particular action it was executing. There's a lot of context being driven up with that. And hopefully, by the end of this presentation, we're going to see where that logging really falls short, and typically what tools end up filling in the gaps. The shout out that I had there is mostly to debuggers. Between logging statements and debuggers, I can change the world. Levers are for chumps in ancient Greece. I'll prefer my my handy GDB and my printouts. And specifically, we want to also have an approach to creating new logging messages, utilizing those logs, and then judging whether or not we've actually done a good job in creating them, or whether or not the authors were getting across the point that they wanted to do. Side note, if anybody comes to me and says that the logging in build farm or any of the code that I maintain is not up to snuff, I take it seriously, and I view these things as very important, especially because it's always about what they're trying to tell you to do in the event of a failure. I can't predict exactly how you're going to use my stuff, and I want to make it as clear as possible how it's going to happen. So here's a slide with printf on it. I owe most of my career to this little statement. You can call it what you will, wherever you will. Printf, string.format, trace dump, progress message, it's really all the same thing. I'm going to try and impress upon you here what this has meant for me, how it gives me confidence, power, prestige, and even in what we call our little sector of the world, fame. The most productive thing that you can do as a software engineer is to reduce the feedback cycle time and energy expenditure between a reproducer of a problem, the validation of that problem, and then experimentation that you're going to use to figure out exactly what went wrong, or rather what you could do to fix it, all facilitated by, at least currently, another software engineer. Meaning they're seeing your output and you are able to see through the mist of what that feedback was trying to give them. Improving this process pays dividends not just linearly in terms of solving problems faster, but it's compounded as your group of similarly processed engineers grows, meaning they're all working more or less the same, expecting the same log messages, and growing accustomed to the same patterns, and then the ability to make them much more effective in practice diagnosticians. They are now able to see problems on a regular basis in more consistent ways because you have presented something either as a software engineer or as a build administrator or as a simple rule maintainer or rule writer, because you're presenting the same kinds of information with unique details that correspond to how they're being used. Logging, or for a more general term, informative, precise, immediate output is the built-in key that lets all of our tools accomplish the cycle reduction goal. There have been a couple of talks already about reducing the cycle, and every single presentation that talks about leveraging a new technology to use a tool has the same pattern. We applied this technology, we applied a new practice, we applied a new algorithm, and we managed to reduce the total build time or the total feedback time for the engineer. The time that you get back, we've sort of thrown it out the wind, 60 minutes, 30 minutes, 20 minutes, but what it means is that engineers lose less context as time goes on, and we're able to make problem solving a routine activity. This thing removes, in addition, logging removes the subjectivity of reporting and qualifies users' actions by guaranteeing that a thing happened. You cannot argue with a log. And we have the evidence of this, and it cannot be ignored. This page was intentionally left blank. There is nothing more frightening to me than a blank page, to me at least. Not having any output leaves me with a feeling of dread. Am I missing something? Where did my life go wrong? Or are we just waiting on a network connection that's stuck open because your kids are wasting all your bandwidth? An empty page speaks volumes, but what it tells you is that you are in one of two circumstances. Either it doesn't work because it hasn't been written, it being whatever you're trying to run, whatever you're trying to do, whatever isn't producing output, or because you didn't tell it to tell you how it's doing. Meaning you didn't write the logging statement, you didn't specify the right option, you didn't get any output from this thing, and the only thing that happened was it hung around. Maybe it exited, maybe it didn't. It doesn't matter. An empty page and a lack of logging information, for the most part, will leave you with no information and no way to make further decisions and have you reaching either for common tools like rebuilding your code when it might not be necessary, or debuggers to try and trace into whatever obscene architecture you've got running. This is wonderful for desktop applications, and it is next to impossible for an embedded machine out in the field. I believe we saw a presentation earlier with code attached to a nozzle sprayer that was sitting in the middle of a field that I guarantee it didn't have internet accessible Wi-Fi. So that's my rant on an empty page and an empty output. Okay, so this is better. This has some information. Wait, no, this isn't good. No, this is a crash. Something's broken. Yes, I got my prompt back. Okay, but we're definitely broken. We're not stuck or continuing on despite these really scary messages, and we're wrong because something went bad. This output, like all logging, is a signal of where our program has been. Yes, it's a stack trace. Yes, it's built into the language, Java in this case. And no, it cannot be brushed aside, and you're foolhardy to ignore it. A user reported this issue to me. They don't have any idea why it's happening, but they have already stood on the shoulders of geniuses for these few lines of unbelievably informative code. I've looked at logs like this for longer than I care to say, and I can mostly pick out things that are important because it's followed a standard that is both informed and without eschewing details in this critical moment of unexpected behavior. And more importantly, the user conveyed this to me without any special training or in-depth investigation to find it. He ran the tool, this tool presented this output, and we can now begin solving the problem of how it came about. Logs aren't there just to be pretty, and programs don't make completely idle statements through them for the sake of making themselves look good. So let's start real quickly discussing what the implications of a log are. The fact that a log exists means that we ran a program, theoretically. We tried to accomplish a goal. This logging itself represents a story told over time from the perspective of the functional components of your program. It's yours in that you conscripted it to do a job for you. This journal that is recorded proves that it took that journey. Assuming that the log didn't exist before you ran it, we can prove that the program ran, it took a particular path, and it accomplished some number of tasks and presented a log. The other advantage typically to logging, and by no means guaranteed, is that it's mostly got relative sequencing. The best logging systems, in addition to the messages themselves containing timestamps, will guarantee exclusivity for messages that proceed one after the other if there's a line-based or a record-based identification of this. So this large winding road of twists and turns and what we saw and what we did as we went along that task is a static thing that we can do a substantial amount of investigation with. The capabilities that this log offers us are pretty wide-reaching. But let's try and cut them into a reasonable set of definitions of things that we want to use them for. At least these are conditions under which we want to understand how things happened. The ability to reconstruct pertinent events to solve several problems is essentially what logging represents. What happened before a failure, and I'm calling this forensics. What did the scene look like in particular before the failure occurred? Why was performance impacted by resource consumption or design? And I'm calling that attribution. What does a build that actually does satisfy the goals do? And that means build, invocation, program tool, execution, take your pick. And that provides me with a comparison. Most of these, employing any of these strategies to solve a problem with the help of a log mostly requires or establishes an a priori understanding of the flow of the program and then the allowable concurrency. And that's allowable concurrency both for execution and for the log messages themselves. Hopefully some copy in the message will provide a glaring indication as to where it came from. From there, the flow of the program will identify the next message that should have occurred. And a great logging message will know that it will be one among many, meaning there is asynchronicity in logging. Tight coupling of logging is mostly different. Especially once you break out into independent components, independent services, independent processes, and then eventually independent computers entirely. These components can be pipelined, totally concurrent, and interference can occur with most of the log recording mechanisms. We could disagree on times, we could disagree on what names are, where things go. Trying to get everything stacked together across a variety of contexts, across a variety of components can end up being difficult. There's a really good case study here, specifically for the interference construct from bazel's history itself. There was and is there was a significant problem with slow activities when performing hashing on builds. And as you've seen from some of the other presentations today, that actually remains a problem. But there was logging associated with that used to print out. Well, we're getting a slow read associated with pulling a particular file off of disk and hashing it. That message was being printed out mostly in a silo, meaning it didn't understand that, yes, your read was slow because you had 10,000 individual worker threads trying to do reads at the same time, and you were exhausting your IOPS. Now, yes, your IOPS were exhausted, but on the whole, no amount of those was able to counteract the fact that you would have thousands of threads being accessing these files at the same time. You would eventually run out of IOPS, making the message sort of chatty and unnecessarily verbose for most builds. And then specifying additional non-logging options can induce more logging. So forensics aren't just crashes. This is any time your program fails to perform what you expect it to. You'll be required to use forensics to prove where you have encountered a problem. Sometimes you wish it crashed, actually. And hopefully this will point to where you wish you had crashed. For examining the crime scene of the broken program's log, messages that do appear guarantee where things had to be, meaning the program had to reach a particular point in order to print out a message. And those that don't appear will be just as telling, indicating that these are the branches not taken, meaning we didn't get through to these points. And for whatever reason, this is canonical proof that, and irrefutable proof that we know to some extent, without adding debugging, without jumping into our process, and without modifying our program in any way, exactly where it had to have been, assuming that we can actually see source, or even if we can't see source, if we have a mechanism to compare it to a reasonable, successful run. Attribution is the inclusion of resource consumption, and specifically it's used in the idea that we can keep track of performance through logging. Whether that deals well with asynchronicity mostly depends on whether or not these are shared resources, or I should say also partitioned resources. In most cases, what we expect to see is an amount of wall clock time consumed, the amount of CPU that we've consumed, whether system or user space, the relative concurrency of one particular activity, or the network consumption disk or RAM, or et cetera. These are essentially different ways of saying that we want to explain the use of time and space and their individualized channel consumption, for each one of those subdivisions. These logs can explain the use of a system. They can also explain starvation, and then they can also further indicate the far-reaching effects of the possibility that you're experiencing any of the above. Any resource exhaustion is, for the most part, going to cause some level of pain associated with your process, because resource consumption begets resource consumption. And the last one is a comparison, or rather is the use of logging for comparison. If your workbench isn't level, you are never going to solve your problem. You are never going to build your door straight. If you cannot compare to a known good, we don't have almost any recourses, especially when we lose source, or especially whenever we can't draw significant comparisons or experiment such that we generate good experiments, generate good results. We'll never be able to identify aberrations within program execution and behavior. The goal here mostly is to denoise the failures, to identify all the things that you don't care about from the failing log and narrow in on specifically what you're interested in because it failed. The one log message that differs, hopefully in a deterministic program and maybe with a lot more magic associated with the organization messages from a highly concurrent program, you're able to determine that these things are irrelevant, and we have to identify this is the section which separated the normal activity of the program from the abnormal activity. So along my experience with logging, I've seen several techniques applied. Silence is typically golden. It would make for boring radio and boring presentations, but whenever I'm asking my compiler to do something, for the most part, I don't want to hear anything from it. If I hear anything from a compiler, either a bad exit status, well, specifically a bad exit status, or any message in general, I assume that I need to take action as a result of that. That means that mostly compilers, linkers, perform your activity and produce me a product and come up with it and leave me alone after that. These systems are often silent. But silence in particular might not be accomplishing the 3 previous goals, or rather, they might not be means to an ends for understanding how things are performing on an ongoing basis, or for comparing the activity of a normal option or a normal build to one that was abnormal or normal execution. So if silence isn't the answer, maybe we have to log it all. Every disk write, every UUID, every minute step along the path, and any possible failure in excruciating detail so that your terminal or editor or aggregator chokes. You'll get your answer all right, but you will need to build up a heavy mental model and index to find it. So obviously too little is wrong, too much is wrong. There has to be a balance struck associated with this. We should have levels and filters and handlers and lots of ways to partition our logs and put the light, gentle ones in front of the kind users running our programs from their terminals, and shove all the other stuff into this append-only dumpster, or maybe just straight into the dev null incinerator. This does keep our user presentation clean-ish, but dramatically increases the complexity of interacting with our logging system. You now need to have more context and be able to select individual things out of your logs, whether at runtime or through detail collection, and we might simply lead to a loss of context, where the right option or level or setting was not enabled at a time to properly observe a transient, sporadic, load, or environment-induced issue. So aside from anti-patterns, I'll highlight what I say the hall of true failures associated with logging. The biggest problem with logs in general is that we tend to over-inject identifiers that might not have anything to do, that the user might not be able to act on. Encapsulating an action ID or a task or a job, something that is ephemeral and mostly non-reproducible, at least in that form. We wouldn't be able to go and ask a system about an ID. Essentially, if you cannot cross-reference with an ID, leave it out. The audience considerations in general, meaning is this person going to understand something? What could it possibly be? I should say a lack of audience consideration, meaning if someone who is not a Java developer or not a build administrator or not a build rules developer sees an error that's 16 miles long and doesn't have any useful information, or even better, is wrapped, the useful information is wrapped in one line by hundreds of other tracewise lines or other unuseful crash information. This will make your tool more difficult to use, and will have problems with logging both internally, reproducibly, as reporting problems, etc. So, sorry, I'm just going to do a quick time check because I've gone over before. Okay. So what about builds? Builds have to be fast and they have to be correct. Bazel's taught us that. We have to choose to. All of these capabilities of logging are central to validating all of build systems' goals, meaning we have to use every single one of them as a strategy to prove that builds and build tools are doing their job correctly. As a large-scale facilitator of builds, like an administrator or remote execution installation maintainer, this is the means by which you determine the health and well-being, which means leveraging statistically significant reports of common messages, and you notice individual aberrations or systemic problems in their patterns. The logs are the only ways to rip this out. What logs to grok and how? Not every log message is useful. Missing any particular branch within the execution of your process is a pain. And I say missing, meaning we took a branch and didn't get any log out of it, and that was the branch that failed. Leveraging your users' exceptional halting recognition. The thing I want to come back to here is that we are really good pattern matching machines. We as in humans. We've gotten even better than maybe everyone else or some other people in general, being build's failure recognition experts. But the way in which processes interact with you as an administrator, as an owner, as someone who sees things and wants to know what's wrong, they need to give you the controls in general for how to dial things up, how to rip out a particular build, how to examine things. So that's pretty much the end of my time. I've got about 8 more slides available to you. Happily share these things, and I want to jump in and see if there's any questions in general.
All right, thank you, George. We have time for 1 or 2 questions. There's one here which asks about your experience and whether also buildfarm supports any of the tools such as open census, open tracing, open telemetry.
So, no, which is very sad to say, but actually lends itself to a slightly different problem or resolution. I just aimed really hard to keep most dependencies out of buildfarm. The goal of buildfarm was to leverage what was baked into a language, the Java util logging, the Java standard logging mechanisms, so that I could put handlers in if necessary, and specifically not tie any particular tie to any platform, tie to any implementation, or expose any details of any internal representation that we had. This was, when I was doing development at Uber. I'm happy to incorporate most of these things, and especially happy if their integration mechanism is a plugin style or the handler injection from Java's standard properties mechanism.
Or for the community to contribute. It's an open source project.